Hello everyone. My name is Abhinav Zindal and today I am presenting my full stack project titled BeatWave, a full stack music player application. Before explaining the project, I would like to briefly share my internship journey and learning background. I joined this internship with a clear goal to become confident in full stack development. Although I had knowledge of HTML, CSS, JavaScript and some React basics, I wanted structured guidance and real-world project experience. My learning roadmap during this internship follow a step-by-step progression. First, I strengthen my front-end fundamentals, understanding responsive layouts, component-based designing, and state handling. Second, I depend my understanding of React architecture, including hooks, lifecycle management, and reusable components. Third, I learned backend development using Node.js and Express, focusing on routing, middleware, API design, and authentication. Finally, I integrated MongoDB for database operations and implemented secure authentication using JWT. The primary objective of this internship were to master the one stack, to understand real-world application architecture, to implement secure authentication, to manage global state efficiently, to debug and solve real production level problems. Throughout this internship, I developed skills in REST API development, JWT authentication, password hashing, Redux state management, database schema design, Git conflict resolution, and performance optimization. BeatWave is a final outcome of this complete learning journey. Project introduction. Music is a universal language. However, many digital music applications lack personalization and seamless experience. The motivation behind BeatWave was to build more than just a basic music player. I wanted to create a personalized user system, secure authentication mechanism, a smooth and uninterrupted playback experience, a responsive design for all devices. BeatWave focus on universal accessibility, meaning anyone can access it through a browser. It also focus on enhanced accessibility by simplifying music management. Most importantly, it ensures a seamless experience, no unnecessary reloads, no broken session, and a smooth transaction between features. The goal was to bridge the gap between a simple static player and a complete data driven music platform. Project overview. BeatWave is a responsive web based application. Being web based means it does not require installation. User can access it from any browser. It is fully responsive, meaning the layout automatically adjusts based on device size, mobile, tablet, or desktop. The application includes secure user login and sign up, real time music playback, search functionality, favorites management, persistent user session. This project is a user centric because every feature is designed keeping experience in mind. Instead of simple music interface, BeatWave behaves like a real dynamic application connected with a backend and database. Internship focus. This internship was focused on mastering full stack development practically. First goal was mastering one stack. This means understanding how MongoDB, Express, React, and Node work together as one system. And the second goal was end-to-end development. I was responsible for backend API design, database schema, front-end integration, state management, deployment readline, The third goal was debugging and problem solving. During development, I faced real issues related to state persistence, asynchronous behavior, and database connectivity. Solving those problems strengthened my understanding of application architecture, technology, and architecture. The project used MERN MongoDB, a flexible NoSQL database that store data in document format. E4 Express, a lightweight backend framework that handle API routing. R4 React, a front-end library that builds UI using reusable components. And N4 Node.js, the runtime environment that execute backend JavaScript. The biggest advantage of Munstack is that everything uses JavaScript, which ensure consistency and reduce context switching. Front-end architecture. The front-end is built using React with Vite. Vite improves build speed and development performance. Redux Toolkit manages global states such as logged in user, current playing song, favorites. Without Redux, passing data across multiple components leads to prop drilling. Tailwind CSS allow utility first styling, making UI responsive and clean. Backend architecture. The backend follows RESTful API principles. Routes are separated into API auth, API song. Controller handles business logic, models define schema. This separation ensures clean code organization and scalability. Database design. MongoDB was chosen for flexibility. User schema stores credentials, favorites. Embedding favorites improve performance because data can be retrieved in one query. Security and authentication. Security is implemented using JWT, and the flow was user logs in, token generated, middleware verifies token. Password are has using Bcrypt. This prevents plain text storage and ensure data protection. Building a modern music player application. Edit profile functionality. This slide highlights the edit profile functionality. One of the important aspects of a user-based application is giving user control over their digital identity. In BeatWave, users can update their username, change their display name, upload or change their avatar, update their password securely. From a technical perspective, I implemented this using a secure patch API endpoint. So why patch? Because patch is used for partial updates, meaning we update only the fields that are modified instead of replacing the entire document. For password updates, I ensure the old password is verified, then the new password is hashed using Bcrypt. Finally, the updated hashed password is stored in MongoDB. For avatar uploads, I integrated ImageKit CDN. The image URL is stored instead of the actual file. This feature required careful validation to prevent unauthorized modification. Overall, this functionality improved personalization and strength application security. ImageKit integration. To optimize media handling, I integrated ImageKit instead of storing image files directly in MongoDB, which increased database size and reduced performance. I used a CDN approach. When a user uploads an image, the file is uploaded to ImageKit. ImageKit generates a secure URL. Only the URL is stored in the database. This approach offers multiple benefits. First, it reduces server storage burden. Second, it improves loading speed because CDN distribute content geographically. And third it makes the system more scalable. If the application grows to thousands of users, media performance remains optimized. This decision reflect real-world production architecture practices. Use audio player custom hook. This slide represents one of the core architectural decision, creating a custom hook called use audio player. In React, custom hooks allow us to extract reusable logic. The use the use audio player hook centralize all playback operations such as play, pause, seek, next, previous, track duration handling, progress updates. Internally, it uses the HTML5 audio API. Instead of placing audio logic inside multiple components, abstract it into one hook, and the benefits is prevents code duplication, ensure consistent playback behavior, make debugging easier, improve maintainability. Any components that needs playback control simply imports this hook. This modular design reflects clean architecture principle. Global search and persistence history. I implemented a global search system that filters songs in real time. As user type, the application dynamically filter results. No page reload occurs. UI update instantly. And for search history, I use local storage. Each user search history is stored using their unique user ID. This ensures personalized history, no cross user data leakage, persistence even after browser refresh. From a perspective, this improves convenience. From a technical perspective, it demonstrates proper client side storage handling. Favorite system. The favorites features allow user to curate their personalized music library. When a user clicks the heart icon, an API request is sent to update the favorite array in MongoDB. The Redux state update immediately. I implemented optimistic UI updates. This means the UI updates instantly. Backend confirmation happens in background. This improves responsiveness. For persistence and on application reload, the app calls the Me API, fetches latest user data, restores Redux state. This ensure favorites never dis- this ensure favorites never disappear between session. Handling session restoration was technically challenging but crucial. Playback features, shuffle and loop features. For shuffle functionality, I implemented the Fisher-Yates algorithm. Why Fisher-Yates? Because it provides true randomization without bias. The algorithm works by iterating backward through the array, swapping each element with a random earlier element. This ensures unpredictability. For loop functionality, users can repeat a single track, repeats entire playlist. These controls are integrated with next and previous track logic. This required careful state management to prevent playback conflicts. The result is a smooth and intuitive listening experience. Responsive UI mobile first approach. The application follow a mobile first design approach using Tailwind CSS responsive utilities. Layout adjust automatically, sidebar collapse on small screens, player remains fixed at bottom. This ensures usability across devices. Mobile first approach ensure better performance and scalability. Clean code practices. I maintained clean code practices throughout development, organized folder structure, separated consent properly, configured .gitignore to exclude node modules, kept repository lightweight, clean code improve maintainability and collaboration. Technical challenges, solutions, and learnings. So one of the biggest challenge during development was state management. Initially, I was passing data from parent components to deeply nested child components. This created a problem called prop drilling. Prop drilling makes the code hard to maintain, difficult to scale, confuse, confusing when debugging. For example, playback state and user data were required in multiple components like sidebar, player, and song list. Passing props manually through each layer made the structure complex. To solve this, I integrated Redux Toolkit. Redux allow me to store authentication data globally, manage playing track globally, and maintain favorites centrally. I also separated global state and local state. Global state means authentication, favorites, and playback, and local state means UI elements like model, open, close. This approach improved code readability, component reusability, and application scalability. This challenge taught me the importance of centralized state management in large applications. Another major challenge was handling asynchronous data properly. Since the frontend communicates with backend APIs, responses are not immediate. Initially, I faced issue where UI would render before data arrived. Some components showed undefined values and playback state mismatch. To fix this, I implemented loading state, conditional rendering, and error handling. Loading state means whenever an API request is sent, a loading spinner is displayed. And the conditional rendering means components render only when required data is available. And the error handling means if an API call fails, user sees a meaningful message instead of broken UI. For examples, if login fails, proper error message shown. If song data fails, fallback UI display. This proactive approach improves user experience, application stability, resilience against backend failures. This challenge strengthened my understanding of asynchronous JavaScript and real-world API behavior. During development, I worked with multiple branches such as feature branch, and main branch, and front-end branch. When merging changes, I encountered Git conflicts. Git, Git conflicts happen when two branches modify the same file and changes overlap. Instead of blindly accepting changes, I carefully analyze difference between versions, missing features, and correct logic combination. I manually merged the branches and tested the build after each merge. This experience taught me importance of version control, writing clean commits, reviewing changes before merging. Git conflict resolution is a very important real world skill, and this project gave me hands on exposure. Challenge for is database connectivity. Connecting backend to MongoDB was another challenge. I encountered an array called econ refuse. This error usually occurs when database server is not running, connection string is incorrect, environment variables are misconfigured. To fix this, I verified MongoDB service status, checked connection string syntax, validate.env file configuration, ensured correct port number. I also implemented proper error logging to detect connection issues faster. This experience highlighted how small configuration mistakes can break entire application. It improved my debugging and backend troubleshooting skills significantly. Balance 5 is CSS and Tailwind integration. Another technical challenge was integrating Tailwind CSS with standard CSS. At times, custom CSS classes were overloading Tailwind utilities, causing unexpected styling issues. To solve this, I updated tailwind.config.js, adjust post CSS configuration, organized custom CSS properly, removed conflicting styles. I also ensured consistent spacing, proper responsive breakpoints, and clean utility uses. This helped maintain a consistent visual design across the application. It taught me that front-end development is not just about logic, but also about structured styling management. So now I demonstrate the key features of BeatWave. First, I will show the sign up and login flow. When a user login, when a user logs in, JWT token is generated, user session is stored, UI update immediately. Next, will select a song. Playback start instantly, current song state updates, clear UI reflects correct track. Now I will add a song to favorites. Hut icon updates immediately. Backend update MongoDB. Redux state update instantly. Next, I will search a song. Results update dynamically without page reload. Finally, I will refresh the browser. Notice user remains logged in. Favorites are restored and playback state remain consistent. This demonstrates complete front-end back-end database integration. Throughout this project, I gained strong practical experience in full stack architecture design, JWT based authentication, Redux state management, REST API creation, database schema design, debugging real production level issues. More importantly, I learned how to think in terms of scalability and maintainability. This project improved both my technical and problem solving skills. In the future, I plan to enhance BeatWave by adding user created playlist, allow user to create and manage multiple playlists, dark mode, improve accessibility and user comfort, mobile application, convert project into React Native app, performance optimization, add caching mechanism and improve API efficiency. These enhancements will transform BeatWave into a more more complete product. I would like to acknowledge the guidance and feedback provided during this internship. Code reviews and architectural discussion help me improve code quality, follow best practices, think in scalable patterns. This internship significantly increased my confidence as a developer. To conclude, a BeatWave is a secure, persistent, and interactive full-stack music application. It demonstrates strong front-end back-end integration, efficient state management, secure authentication, scalable architecture. This project transform my theoretical knowledge into a practical application building skills. Thank you for your time. I'm happy to answer any questions.